Okay, so let's have a look at this first question. An EM field travels in the positive Z direction. The magnetic component of the wave is given by this equation. B equals 12.25 picoteslas sine 0.780 Z minus 2.340 times 10 to the 8 TJ, where Z is in meters and T is in seconds. So A, what is the wavelength of the wave in meters? So to do this first bit, what is wavelength related to in our equation? So we know it's related to K. So in our equation, K equals 0.780 meters to the minus 1. And we also know that K is 2 pi divided by wavelength. Therefore, the wavelength is 2 pi divided by K, which is 2 pi divided by 0.780. And that equals 8.055 meters. Or to 3 significant figures, it would be 8.06 meters. So that's part A. Part B, what is the NI is equation of the electric component of the wave. Okay, so for the electric component, this is the form that our equation is going to take. And then this has some unit vector, and we have our units, which will be, say, volts per meter. Okay, so the thing that we don't know, we know what K is. It's going to be exactly the same up here. We know what omega is. It's going to be the same as well. The only thing that we don't know is what's the unit vector and what's Emax. So let's work out what Emax is first. Now, Emax is related to Bmax using our formula C equals E divided by B. Therefore, the max of the electric field is going to be C times Bmax. And for our scenario here, Bmax equals 12.25 picoteslas, which is 12.25 times 10 to the minus 12 teslas. And then when we do that, we get 0.003675 volts per meter, which to 3 significant figures is going to be 3.68 millivolts per meter. So that's part BI, because part 2 is the unit vector of the electric component. So for this part, we need to work out in which direction is our wave propagating and what is the unit vector of our B. And we have to use our right-hand rule to do this. So you're going to need to imagine X, Y, Z. I've drawn our Cartesian plane. This is where our EM wave is propagating, and our B field, our magnetic field, is oscillating in the Y direction and has the unit vector J. So remember, using our right-hand rule, our thumb must point in the Z, positive Z direction. Our fingers must curl towards the Y. Therefore, the E field must have the unit vector I. So therefore, it has the unit vector I. So our equation is going to be... Oh, I realized I didn't finish the equation down here. So I might as well just write it all out here. So that's the answer for part B2. And then part C. Which term best describes the wave? Radio, microwave, infrared, visible, UV, gamma, or X-ray? Our wave, the easiest way to work this out is by looking at the wavelength. What is the wavelength? And that's going to dictate what type of radiation it is. So our wave here has very long wavelengths. It's 8 meters. So we'll say long wavelengths, around 8 meters. Therefore, this is going to be a radio wave. And that's the answer to this question.